All right, so we just finished talking about standing sound waves. The next section is actually pretty random and extremely short, so that should be only a couple minutes, a couple minute video. However, I do recommend watching the pre-lecture video 3, which is the physics of your vocal system. He actually does a really cool demo in there dealing with an artificial larynx, which gets into a little bit of how your vocal system actually works. Really cool, kind of interesting thing to think about, but real quickly in this section, we're just going to talk about speech and hearing as it pertains to you. So when you hear something, it's not just, you don't hear pure tones. Most sounds that you hear are actually a mix of several different frequencies, but your ears can only pick up one actual sound. And that gets into the concept not necessarily of the frequency, but rather the timbre, speaking musically of what you hear. So the frequency spectrum is actually a mix of different pitches or different frequencies, their relative intensities, and what you hear. So your brain interprets these. It interprets the fundamental frequency as the pitch, and then it uses the higher frequencies to determine the tone quality or timbre. So here, the fundamental frequency is 262 hertz, but above that, any multiple of 262 can be heard as well. So here we have, for example, we have 524. Well, that would be, if this is my m equals 1, then 524 would be m equals 2, 786 would be m equals 3, 1084 would be m equals 4, etc. So when there is a fundamental frequency, there are also overtones, as they're often referred to, or other harmonics that are simultaneously playing at the same time. So a consequence of this is the concept of timbre. It means that, I could have a trumpet and a flute, or a trumpet and a saxophone playing the same frequency, but they sound different. They sound like different instruments, not because they're playing different notes, but because of the overtones that you hear beyond that fundamental frequency. And that's how your brain interprets the concept of tone quality or timbre. Now, when we look at the tone quality, if we were to actually try to graph out our pressure as a function of time waves, this is why a trumpet has its own unique fingerprint, that is this image right here, that makes the sound wave sound different versus something that's like played on a guitar. The frequency spectrum is slightly different. The higher harmonics themselves don't change the period of the sound wave, they change the shape of the sound wave. So if I had a pure tone, for example, I would get a nice sinusoidal curve. But because I don't have a pure tone, I have instead a trumpet, then I get this messy kind of periodic wave that still follows that sine wave shape, but doesn't exactly give me the same perfect curve. And that's what makes instruments or different things or even different people sound different. Now, when we think about speech itself, the very first thing is that your vocal cords are stretching and they are vibrating. Your vocal cords produce a mix of different frequencies, and this is what he talked about in the pre-lecture video. So your larynx produces all these different frequencies as they vibrate. Now, there's a mix between the fundamental frequency and there's a mix of higher harmonics. And that's what gives that sound quality from your vocal cords. This creates the pitch of your voice, and your vocal cords are changed by, and the fundamental is changed by changing the tension in your vocal cords. So if I think, like if I want to, if I'm singing, which I try not to, if I'm trying to sing a very, very high pitch, I really have to stretch out my vocal cords. And why is that? Well, if we go back to the concept where the velocity, if we treat our vocal cords like a string, then the velocity of this string is the square root of the tension over the linear mass density of the string, which is, again, that mass per length. So as I increase that tension, I'm going to increase the velocity. And we know that velocity equals frequency times wavelength. So the wavelength of my vocal cord stays the same. So if my velocity goes up, then my frequency will go up as well. So people that are untrained properly for singing, and they do a lot of singing, they develop something called nodes, which is when they are improperly singing these higher pitches, their vocal cords can, because of it, tend to strengthen out, and it actually causes issues with the vocal cords. Now, there's a lot of analysis that we could do with it. So sound, after it hits after your larynx is vibrating, it goes through your vocal tract, and that's what makes really all of us a unique sound. So it goes through the throat, your mouth, your nose. These all act like tubes or resonating chambers. Now, those waves, as they're resonating inside your throat, they are forming what are called formants. So those are the standing waves in your vocal tract. And what you do is you change the shape of your formant and the frequency, and therefore that changes the actual sounds that you make by changing your mouth position, the opening of your mouth, and the position of your tongue. So as you're talking, think about, now we do this naturally, like we do this very quickly, we do this very naturally. But as I'm talking right now, if I pay attention to like what my tongue is doing, it's always forming in different shapes. It's my mouth is forming in different shapes depending on what I'm saying. So it's really crazy how fast we know to do this because of muscle memory. And that makes sense then why it could take people a long time to learn how to talk, because there's a lot of things that are going on. So this graph right here, or whatever you want to call it, is somebody making an E sound. So when I think about E, right? E, do it with me, come on. E. I think about where my tongue position is. My tongue position is pretty close to the roof of my mouth. E. My throat is kind of like stretched out, like it feels open. But anyway, the relative intensity changes the formants. It changes the frequency, it changes the sound quality, and that gives me that nice E sound. And every single thing that we say has its own unique position that makes it sound the way it sounds. It's crazy. But anyway, so that's actually it for the whole concept of speech and hearing. Hopefully I didn't make too long of a video out of this. And again, feel free to check out that pre-lecture video. And that actually does a couple interesting demos as well. Now we're going to close off this chapter by taking a look at what happens when I have multiple sources of sound and how they interfere with each other. And we'll be doing that in the next segment.